Welcome to the 7th mini lecture in 7503 NSC Aviation Economics. The previous lecture we spoke about airline scheduling, and we spoke about all the problems that go with airline scheduling. And of course we said that in the airline planning model that's linked also to fleet planning. That is, when you know the routes you're flying, then you can plan the fleet that you've got or changes to the fleet you've got. And that's exactly what we're going to be doing this lecture, airline fleet planning, and this is a very applied lecture. What we're going to be doing is describing the importance of fleet planning and its long-range implications. That is, being able to look well out in advance, because very often there are long lead times involved in upgrading your fleet. We're going to explain how the changes since deregulation have affected the fleet planning process, including new aircraft technology, and we'll take a look at the two major airline manufacturers and take a look at their approach to their aircraft and how they produce aircraft to meet certain fleet planning requirements. We're going to talk about the system constraints and the constrained operating plan in doing fleet planning. We're going to talk about the elements that must be considered by an individual carrier in evaluating a particular aircraft, and of course we're going to be discussing the different requirements that the aircraft manufacturers have to consider. And of course we'll be looking at the two major aircraft manufacturers, but of course we know there are a number of others that are coming to the field, and there are more coming in, especially in China. First of all, if we talk about interfacing the network planning side with the fleet management, the one thing that we know is the route and the network management drives the fleet management. That is, when you know the routes that you're flying and also how you link in with other airlines, it really helps you starting your planning. And so that's good if you start with a clean sheet of paper. But very often what we have is an airline that's been in the business for years and their routes are changing. For example, we know that Qantas has got rid of certain routes, such as the Bangkok to London Heathrow route, but it's expanded into South America. So even though it has a fleet, it is based on a past plan, and of course they have to look at their future plan as well. So having a look at the network that you're operating and also trying to predict how you're going to be doing the changes to meet the future network requirements is always a very, very big ask. And of course, when we look at the scheduling to meet that network, then of course we get other factors coming into play. And so the big thing is, similar to the example I gave before, suppose an airline wants to establish a service for a non-hub origin destination market with 400 passengers a day. The ideal way would be to go to one aircraft that can carry 400 people. But of course the thing is, does that fit in with passengers who might not want to fly at the time that that aircraft is departing? And so the big thing is that people may not want to fly at a once a day departure, and secondly, they may not want to fly on an aircraft that's got high density seating for 400 people. So this is what airlines have to consider. So if we look at factors in fleet planning, we've got the impact of deregulation. And that's an important one because, of course, that opened up, first of all, new competition and also different ways in which competitors could meet that competition. We look at the hub and spoke system itself, which, of course, was brought in as a way of basically trying to bring efficiencies into the system. But what we know now is that people don't like flying through busy hubs sometimes, such as Los Angeles, with all the problems of changing aircraft, etc. And so airlines are now looking at ways of flying point to point. That is, if you want to fly from Sydney to Dallas, wouldn't it be better to be able to fly direct rather than have to go to Los Angeles, change aircraft and get another flight from Los Angeles to Dallas? There are the technical factors that we bring in. Of course, the one thing is that an aircraft that's out of service going through maintenance is not earning money. And so if you've got a modern fleet that may not need heavy maintenance until 12 years after you've purchased it, such as a Boeing 787, that makes a huge difference in your costs, not only of maintenance itself, but having the aircraft out of service. If we look at the other technical factor considerations that come in, we've got the system factors. And we look at the structure and flight controls, and we know the Airbus 350 and the 787 have got a lot of carbon fibre composites. We now have fly-by-wire systems. And of course, the big difference is a Boeing aircraft has a yoke system, and some people like a yoke system. An Airbus aircraft has a simple side hand controller, and some people like that, some people don't. We get the mechanical systems. The more mechanical systems there are in an aircraft, the more maintenance. And airlines are looking at ways of making mechanical systems low maintenance. That is like your car, it doesn't have to be looked at so often. Avionics and instrument systems. Obviously, with more aircraft flying, there's high density airspace. So people want to have good instrumentation so that they can fly according to the new rules, such as the introduction of automatic dependent surveillance broadcast systems, ADS-B. We look at the propulsion systems. They make a huge difference. Look at the new engines that are going to be on the Airbus 320 new engine option and the Boeing 737 MAX. Those engines can make a difference of 15 to 20% in fuel burn. So these are important. Then we look at other design features, such as what is the aircraft designed to actually achieve. That is, an Airbus 380 is designed to achieve different objectives from an Airbus 350 or a Boeing 777. We've got the safety, reliability, redundancy, maintainability, simplicity. All of these add up to the cost of ownership, use of proven technology. That is, it's all very well to bring in that new technology, but sometimes it can cause problems, such as the use of lithium-ion batteries on the Boeing 787. Ease of integration with current staff skills and infrastructure. That is, if we can bring in an aircraft without having a whole stack of new training and new spares, etc., that's a big thing. Then, of course, payload to weight ratio, and then performance analysis. We'll be looking at all of these in the details of the lecture itself. If we look at factors in the fleet planning itself, as we've said, we look at all of these factors in very, very great detail. And of course, one of the things that we look at is fleet rationalisation and commonality. This is a big one because the more types you have in your fleet, the higher the cost of ownership in having another logistics system to support them. Long-range aircraft. A long-range aircraft can mean that you're cutting down at a call where you have the costs of turnaround and other features such as disruption to the passenger schedule. And then, of course, we have this one, the trend towards leasing. And we'll do that in a further lecture in much greater detail, but we still look at it as being a factor in fleet planning itself. And, of course, noise restrictions. For example, some of the older aircraft, we can't operate during airline curfew time simply because of the noise that they make. So these can make a big difference. If we look at fleet rationalisation and commonality, we know that airline industry that behaves under the conditions of oligopoly. That is, there aren't a lot of players about in certain areas. For example, in North America and the United States, there are only really 4 major carriers there now. In Australia, there are really only 2 major carriers, and then their various subsidiaries. So all of this means that airlines operate with a tacit understanding amongst themselves that, well, we won't really try to undercut each other, or else we'll be cutting our own throats. The thing is that we know that new aircraft acquisition is expensive. And so the thing is, people have to look at, well, what are our long-term needs, especially if it's getting cost down. If we can get commonality and not have too many different types, that is a big thing that we can do. And also consolidation. That is, if we actually take a look and say, well, would we be better, rather than competing against some, looking at a merger amongst ourselves? And also, can we actually take a look at working together with the engine manufacturers more closely to try to get the aircraft we want? These are things that are important for us to take a look at. If we look at the fleet planning process itself, we get a number of approaches. We get the top-down approach. This is where the executives, the senior leadership team on airlines, who have got a lot of experience and know pretty much what it takes to run an airline, where they can look at the problems in aggregate and say, well, this is what we think from our experience should be happening. But then we have to have a bottom-up approach where we have to look at all the individual routes themselves, the schedules that we're operating to, the particular economics of those operations, and say, well, how is that going to affect our planning? We're going to have to take a look at putting the specifications for everything we need together, doing a marketing analysis, for example, finding out what do our customers want, what's our fleet planning model, how are we actually going to plan for the future as to what we want, so that we try to consolidate the number of types down and also try to get as much commonality amongst our systems as possible. What are the other system constraints operating out there? For example, do we want aircraft that if a particular route may dry up in the future, it can be switched to another route without too much problems? How do we go about evaluating our aircraft? And what are all of the financial factors we've got to take in? And then how do we present that to our actual senior management to get them to approve? And so here we have a fleet planning evaluation model. This was developed by McDonnell Douglas back in 1981 and is still pretty much used around the industry. And we'll be going through that model. But as you can see, it starts with the traffic forecast. Now, remember we spoke in a previous lecture about the importance of forecasting. And then we can see the different terms that we've already done in previous lectures: the yield analysis, operating revenues, load factors, air-sea kilometre requirements, aircraft required by type, operating costs, depreciating. These are all things we've covered in previous lectures. The operating profit forecast, that comes from our strategic planning. Cost of interest, we've looked at that previously. Non-operating incomes. And then basically we come down to the debt to equity ratio that we end up coming up with. And this is, of course, is bringing in some of the new terms. And of course, debt to equity is very much a factor. This is another metric that is important to an airline. So this model, it's a proven model. It's been going for over 40 years now. And basically we can see, 35 years, and we can see that it's one that if we understand that, we can understand a little bit more about fleet evaluation. With aircraft evaluation, we look at the design characteristics, the physical performance itself, the maintenance needs. For example, we know a Boeing 787 doesn't need its heavy maintenance until after 12 years. That's a big cost saver. The acquisition cost itself, that is, do we have the money to buy it, or do we have to go out and borrow? We'll be looking at those costs and saying, well, perhaps it may be leasing. And what are the operating economics? And of course, what we know is, since the Boeing 787 has come in, for example, flying from Melbourne to Hawaii, we now know that we're saving about 5 tonnes of fuel by putting a 787 on that route now, rather than using an older Airbus 330. So these make a difference. We'll be showing you how to read the graphs so we get to understand the Payload range analysis. That is, we know that an aircraft, if it flies empty, will have a very extended range, but as we put more and more passengers on, we have to reduce the range. We'll be able to find out as to what optimum range is for the carriage of passengers. Being able to understand graphs such as this will give us a greater understanding of how the airline can operate to get the best out of the fleet that it purchases. If we look at the fleet planning and financial evaluation, we find that what the airline comes up with is recommendations. And very often what airlines have to do is say, well, what are our proposed firm orders? Because if we put in a firm order, then Airbus or Boeing or Bombardier or Embraer will put us at a certain point in the queue. But if we can't have firm orders, then we take a place further down the queue. But even if we put in options, that is, we say, well, we'll definitely buy these, but we want options for others, this gives us more favoured staying. So what we can do is we can take a look at proposed orders, options to purchase, and then what are the actual aircraft that we plan for the future, and what is the number that we're planning to also phase out. So these are all factors that will be going into greater detail on the lecture itself and the course, to give you an idea as to how the airlines actually go into the game interfacing with the manufacturers to in fact get the best deals possible, but also to ensure that they're meeting their long range forecasts. We look at the different approaches of the two airlines, and we look at Boeing and Airbus as two of the major ones. And what we know is that they were pretty different about 20 years ago. But as time has gone by, the two of them are now getting closer and closer together in what they're actually producing in terms of aircraft. So the 787 is pretty closely matched to the Airbus 350. And what we know is that aircraft now are a huge investment. Airlines have to really think carefully about, do we want to produce this type of aircraft? For example, the Airbus 340 has had actually a very, very short life because people said it's got 4 engines and we can do the same with 2 engines, much greater economy. So it's important for people to look at the long lead times and say, is the aircraft we're looking at today going to be popular with a customer in 12 years' time when it first comes out? We're looking at production, and what we're seeing now is more and more outsourcing. Boeing is becoming more an assembly place for aircraft, with contractors producing parts of the aircraft which are then brought into the assembly plants and then put together. Then we're looking at all the support side. For example, an aircraft without the right number of spares ends up sitting on the ground. That's a waste of time. So we have to look at everything that's done to support that. And both sides have their own logistics support specialists to support their aircraft. If we look at Airbus, very, very similar. It started off with fly-by-wire. It started off with standardised cockpit design. It was pretty much first to start using a just-in-time inventory. But Boeing and Airbus have now got very, very closely together. The big difference is, of course, Airbus has got the 380. Boeing doesn't have an equivalent aircraft at the moment. The 787-8 may be close, but there are still very, very big differences. And so the big thing is that Airbus has been very much a very strong innovator, but the two are close together. The one thing that Airbus has been very strong on, that Boeing is still catching up on, is the commonality among types. So in summary, we've covered the fleet planning and its long-range implications, and this is something, because of the long lead times that are required for new aircraft to come on board, airlines have got to be looking out well in advance and looking at their forecasts. We've been looking at the industry changes, and we've been looking at the inputs to the fleet planning process and explaining their meaning and showing how airlines actually go through right to tabling the recommendations for final approval. We've looked at the two approaches to the fleet planning process, the top-down and the bottom-up, and we've looked at system constraints and the constrained operating plan just touching the surface. We've looked at the elements that have got to be considered in terms of what are we looking for in our aircraft, the design characteristics, the propulsion, the support side, and we've looked at the different approaches that the two manufacturers adopt in producing aircraft for the airlines. This is a very, very applied lecture. It's a very important one, though, because of the way it impacts into the airline planning model and flows on to the future economics that we see coming out to decide as to how much the profit that an airline is going to make. This is showing up with some of the new types coming online now, and it'll show up even stronger, particularly when oil eventually starts its rise up the chart again. Thank you.